In this video, we are going to learn the properties of operations on real numbers. How should numbers be added, subtracted, multiplied, and divided? Does it matter what we do first, second, third? Can we add the numbers together in any order? Regardless of the order, will the answer be the same? Can we multiply the numbers together in any order? Regardless of the order, will the answer be the same? The following properties of operations on real numbers will answer our questions. Let's start with closure property. Closure property of addition. If you add two real numbers, the sum is also a real number. Closure property of multiplication. If you multiply two real numbers, the product is also a real number. Let us have more examples showing closure property of addition. If you look at the given examples, the addends are all real numbers, and their sums are also real numbers. Look at these given examples showing the closure property of multiplication. The factors are real numbers, and the products are real numbers also. Real numbers are closed with respect to addition and multiplication, but not closed to division. A real number cannot be divided by 0. Example, 7 divided by 0 is not equal to 7. Or even 7 divided by 0 is not equal to 0, because 7 divided by 0 is undefined. Next, we have commutative property. Commutative property of addition. If you add two real numbers in any order, the sum will always be the same. Commutative property of multiplication. If you multiply two real numbers in any order, the product will always be the same. Consider these examples using commutative property of addition. 1. 4 plus 6 equals 6 plus 4. 4 plus 6 equals 10, 6 plus 4 equals 10. Number 2. 25 plus 8 is equal to 8 plus 25. 25 plus 8 equals 33. 8 plus 25 equals 33. Since 10 is equal to 10 and 33 is equal to 33, then the commutative property holds true for addition. Here are more examples showing commutative property of multiplication. Number 1. 7 times 8 equals 8 times 7. 7 times 8 equals 56, and 8 times 7 is 56. Number 2. 9 times 6 equals 6 times 9. 9 times 6 equals 54. 6 times 9 equals 54. Since 56 is equal to 56, and 54 equals 54, then the commutative property holds true for multiplication. The previous examples show that we can apply the commutative property to addition and multiplication. But if we move the position of the numbers in subtraction and division, it changes the problem and therefore changes the answer. Example, is 8 minus 2 equal to 2 minus 8? 8 minus 2 equals 6, while 2 minus 8 equals negative 6. 6 is not equal to negative 6. Therefore, 8 minus 2 is not equal to 2 minus 8. Next, is 8 divided by 2 equal to 2 divided by 8? 8 divided by 2 is 4. 2 divided by 8 is equal to 1 over 4. 4 is not equal to 1 over 4. Therefore, 8 divided by 2 is not equal to 2 divided by 8. Did you know that the commutative property got its name from the word commute? which means move around or travel. Let's now have associative property. Associative property of addition. If you're adding three real numbers, the sum is always the same, regardless of their grouping. Associative property of multiplication. If you are multiplying three real numbers, the product is always the same, regardless of their grouping. Here are more examples showing the associative property of addition. Number 1. 6 plus the sum of 3 and 5 is equal to the sum of 6 and 3 plus 5. 6 plus 8 is equal to 9 plus 5. 6 plus 8 equals 14, and 9 plus 5 is also equal to 14. Number 2. The sum of 39 and 14 plus 6 is equal to 39 plus the sum of 14 and 6. 53 plus 6 is equal to 39 plus 20. 59 is equal to 59. If you look at example number 2, it is easier to do calculations by adding 14 and 6 first rather than adding 39 and 14. Consider the following examples showing the associative property of multiplication. Number 1. 5 times the product of 2 and 8 is equal to the product of 5 and 2 times 8. 5 times 16 is equal to 10 times 8. 5 times 16 equals 80. 10 times 8 is also equal to 80. Number 2. The product of 11 and 4 times 5 is equal to 11 times the product of 4 and 5. 44 times 5 is equal to 11 times 20. 44 times 5 is 220. 11 times 20 equals 220. Observe that in number 1, it is easier to multiply 10 and 8 than 5 and 16. And in number 2, the product of 11 and 20 is easier to get than the product of 44 and 5. Thus, by grouping, it makes calculations of multiplication easier and faster. By grouping, we can create small components to solve, which makes calculations of addition or multiplication easier and faster. We cannot apply the associative property to subtraction or division. When we change the grouping in subtraction or division, the answer changes. Example, is 9 minus the difference between 6 and 2 equal to the difference between 9 and 6 minus 2? Is 9 minus 4 equal to 3 minus 2? 9 minus 4 equals 5, 3 minus 2 equals 1. 5 is not equal to 1, and therefore 9 minus the difference between 6 and 2 is not equal to the difference between 9 and 6 minus 2. Next, 40 divided by the quotient between 4 and 2 is equal to the quotient between 40 and 4 divided by 2. Is 40 divided by 2 equal to 10 divided by 2? 40 divided by 2 equals 20. 10 divided by 2 is equals to 5. 20 is not equal to 5. And therefore 40 divided by the quotient between 4 and 2 is not equal to the quotient between 40 and 4 divided by 2. Did you know that the associative property got its name from the word associate, which means to group? Let's take a look at the identity property. Additive identity property. If you add a real number to 0, the sum will be the original number itself. Multiplicative identity property. If you multiply a real number to 1, you will get the original number itself. 0 is called the additive identity, while 1 is called the multiplicative identity. The identity property holds true for subtraction as well, because subtracting 0 from any number equals the number itself. Therefore, 0 is also called a subtractive identity. The identity property holds true for division as well, because dividing any number by 1 equals the number itself. Therefore, 1 is also called a divisive identity. Let us proceed with inverse property. Additive inverse property. If you add a real number and its opposite, you'll always get 0. Multiplicative inverse property. If you multiply a non-zero real number by its inverse or reciprocal, the product will always be 1. The additive inverse of a number is the same number with the opposite sign. When a number and its additive inverse are added to each other, the result is always 0, the identity element for addition. The multiplicative inverse of a number is a reciprocal of that number. When a number and its multiplicative inverse are multiplied by each other, the result is always 1, the identity element for multiplication. The distributive property of multiplication over addition can be used when we multiply a number by a sum. Here are other examples using the distributive property. Number 1. 3 times the sum of 5 and 6 is equal to 3 times 5 plus 3 times 6. 3 times 5 is 15, 3 times 6 is 18. 15 plus 18 is 33. Now, without using the distributive property, we have 3 times 11 equals 33. Number 2. The sum of 5 and 6 times 3 is equal to 5 times 3 plus 6 times 3. 5 times 3 is 15. 6 times 3 is equal to 18. 15 plus 18 is equal to 33. Distributive property can be used with subtraction as well, multiplying each number in the difference before subtracting. Example, 7 times the difference between 8 and 6 is equal to 7 times 8 minus 7 times 6, which is equal to 56 minus 42. 56 minus 42 equals 14. Again, the properties of operations on real numbers are closure property, commutative property, associative property, identity property, inverse property, and distributive property. And that will be all. Thank you.